Okay, today we're going to do some CPU scheduling practice. This is going to be non-preemptive, first come, first serve, shortest job first, and priority. So just as a quick review, non-preemptive versus preemptive algorithms. Non-preemptive algorithms mean once the process gets on the CPU, even if a higher priority or any other circumstance happens, the process does not relinquish the CPU until it has finished its current burst. That's non-preemptive. And we will be calculating turnaround time, waiting time, and response time. And these will be calculated per process, and then I will discuss how you calculate the averages. So if you need to review this, go back to the older video, which was posted before this, and you can review how to make these calculations. All right, so let's get started. Here we are with first come, first serve. First come, first serve, we're going to now calculate, we're going to make a Gantt chart and run through the first come, first serve algorithm. So here's our Gantt chart. And what we have here are 5 processes, and our timing diagram starts at time 0, and we just run the processes onto the CPU. This represents the CPU in the order in which they arrive, and once they get the CPU, they do not relinquish it. So P1 will go and we'll have the CPU for 8 time units, followed by P2, which you notice the arrival times are here in the first column and the CPU bursts are in the second column. Be sure not to mix up the arrival times with the CPU bursts. So P2 goes next on the processor and will go until time 13, followed by P3, which we'll get on the processor for 10 time units until time 23, P4 until time 32, and P5 until time 39. And one thing, if you were to add up all of the CPU bursts right here, it should equal 39 because this is 100% CPU utilization, which means that the processor was busy the entire time with all 5 processes, and therefore then the CPU bursts altogether would add up to that amount. Now this is a very simple, straightforward first come, first serve. And another thing that we will notice now when we calculate our response time, because response time is the first measure of wait time, for this situation we will only have the same response time and the same wait time because the processes only go on the CPU one time. So let's get started calculating. So to calculate the response time or wait time, you calculate the response time is a first time measure from the time when the process gets admitted. In this case, P1 was admitted at time 0, and the first time P1 got on the processor was at time 0. So P1's response time is therefore going to be 0. Now, since P1 only did not go back into the ready queue and wait any additional time, the wait time will also be 0. But in future exercises, you will see where the response time and the wait time will not be the same. P2 arrived at time 3, first got the processor at time 8, so P2's response time is 5. P3 arrived at time 4 and first got the processor at time 13, so it's 9. P4 arrived at time 6, first got on the CPU at time 23, so the response time is 17. And P5 arrived at time 11 and first got on the processor at time 32, so has a response time of 21. Now, in order to calculate the average, all you do is add up these 5, get the total of this and divide it by 5 because there are 5 processes. So the average here would be then 10.4. Okay, so now let's calculate the turnaround time. To calculate the turnaround time, you take from the time the process completed all execution. That means it's the total time it was on the CPU and waiting for the CPU and waiting for events, the total time active in the system. And in this case, it's very simple. P1 arrived at time 0 and completed everything it needed to do by time 8. So P1's turnaround time, therefore, is going to be 8. P2 finished everything it needed to do at time 13 and arrived at time 3, so P2's turnaround time will be 10. P3 finished everything at time 23 and arrived at time 4, so P3's turnaround time is going to be 19. And you will notice that if you add up the wait time and the CPU burst time, you will get the turnaround time, because each process, after it gets into the system, it is either waiting or on the CPU. P4 finished at time 32 and arrived at time 6, so P4's turnaround time is 26. And P5 finished at time 39 and arrived at time 11, so P5's turnaround time is 28. And just like before, you can calculate the average by adding up all of these 5 numbers and dividing by 5. And in this case, the average turnaround time is 18.2. Now, what does this information mean? Well, it means that if you were to run these processes in the first come, first serve algorithm, then this is how the results would be. This is the average amount of time each process would have to wait, and the average amount of time it would take to complete these 5 tasks. So let's move on now to shortest job first, and we're going to do the same exercise with the same processes. We will start at time 0, and the way shortest job first is, it's a priority-based algorithm, and instead of having an assigned number for the priority, what happens is the processes get the priority based on their CPU burst. Now, of course, this is not very realistic, because it's very hard to know how long a CPU burst is going to be. But in the other videos, I did show you some examples of things that can be done to help to put the shorter jobs in front, because shortest job first will give the minimum average waiting time in most circumstances. All right, so the current time is 0. The only process that has currently arrived is P1, so P1 will go first. And it will go until time 8. Now, this is shortest job first non-preemptive, so it doesn't matter if another process arrives. P1 is going to finish its burst because it's non-preemptive. Now, at time 8, we have in our ready queue P2, P3, and P4. They all arrived, and so we're going to have to put the next one on based on the CPU burst. And so the one with the shortest CPU burst is P2, which will go until time 13. And next we will have, at time 13, we have P3, P4, and P5 all in the ready queue. So we will run P5 next until time 20, followed by P4 until time 29. And then lastly, P3 until time 39. And as you can see, since this is the same set of processes with the same CPU bursts, it takes, and it's 100% CPU utilization, it takes 39 time units. Now we do the same thing to calculate the response time. P1 arrived at time 0. The first time it got on the processor was time 0. Let me get another color here. So P1 arrived at time 0 and got their time 0, and so waited 0 time units. P2 arrived at time 3, so P2 waited 5 time units. P3 arrived at time 4 and waited until time 29, so P3 waited 25 time units. And P4 arrived at time 6 and waited until time 20, so 14 time units. And P5 arrived at time 11 and waited until time 13, so P5 waited 2 time units. And again, if you want to calculate the average, you just add up all of these and divide by 5, and you would get the average. In this case, the average is going to be 9.2. All right, so now let's calculate the turnaround time. So you take the last entry on the Gantt chart and subtract the arrival time. So P1, turnaround time is 8. P2 finished at time 13, arrived at time 3, so P2's turnaround time is 10. P3 finished at time 39 and arrived at time 4, so has a 35. P4 finished at time 29 and arrived at time 6, so it would be 23. And P5 finished at time 20 and arrived at time 11, so P5's turnaround time is 9. And if you add up those numbers and divide by 5, you would get the average, which would then be 17. And if we go back and take a look, we can see that the averages for shortest job first are, this is a very simple exercise, but the averages are better for shortest job first. All right, let's do this one last exercise in this video, and this is doing it priority. Now, we're not going to do preemptive priority, we're just going to do priority. So let's draw our Gantt chart. These are the same processes with the same arrival times and the same CPU burst times, only in this case we've assigned priorities, and priority 1 is the highest. So priority 1 is higher. All right, so this is non-preemptive. So at time 0, the only process that is there is going to be P1. So P1 will have the CPU until time 8. Now the current time is 8, and in our so in the we have P2, we have P3, and we have P4 are all in the ready queue. P5 has not arrived yet, so we have to make a choice based on these that are in the ready queue, which has the higher priority. Well, P2 and P3 both have our priority 1. However, if you have more than one with the same priority, then the tie is broken by the one by first come, first serve. So the next to go would be P2, since it arrived there before P3. And so P2 has a CPU burst of 5. We'll go until time 13. Now the current time is 13. We have in the ready queue, we have P5 and P4 and P3. And P4 has a priority 1. P5 also has a priority 1. However, P4 has a priority 2. P3 has a priority 1. And P3 got there first, so P3 is going to go next. And now the only ones left in the ready queue are P4 and P5. And P5 will go next. And then the last one to go will be P4. So once again, it takes 39 time units, and you can calculate the response times and the turnaround times. So we have P1 arrived at time 0, response time of 0. P2 arrived at time 3, response time of 5. P3 arrived at time 4, has a response time of 9. P4 arrived at time 6, has a response time of 24. And P5 arrived at time 11 and has a response time of 12. And you can add this up and divide it by 5, and you would get the average. And then we have the turnaround time. P1 finished at time 8, arrived at time 0. P2 finished at time 13, arrived at time 3. P3 finished at time 23 and arrived at time 4. P4 finished at time 39 and arrived at time 6. And P5 finished at time 30 and arrived at time 11. So I hope this helps you to understand how to get started doing these algorithms, and in the next video we will do all of these algorithms, all of the preemptive versions of these algorithms.